All right, this is topic 1 for module 1, and this is a level 2 skill that we are going to start out with. So this level 2 skill that we are working on today is solving two-step equations and inequalities in one variable by isolating the variable using inverse operations. So these are kind of, these should be a review from last year. And remember, this is just a small part of our scale, A2, RE, I, A1, okay? So just because we reach the level 2 on this specific skill does not mean we have a level 2 on the whole scale. It's just a part of it. All right, let's start off by talking about what an inverse operation is. Inverse operations are pairs of mathematical manipulations in which one operation undoes the action of the other. So think like opposites. Inverse kind of means the opposite operation. So the opposite of addition would be subtraction. They undo each other. The opposite of multiplication is division. Those undo each other. Okay, so first set of examples, these are really simple. These are called one-step equations, and these just use simple inverse operations. So I have x minus 7 equals 3. Now, if you are just starting off with solving equations and you don't really know much yet, think of this like a box. It's kind of like a question mark. What minus 7 gives you 3? So the opposite of minus 7 would be adding. So if we add 7 to both sides to get x by itself, we get x equals 10. And you could always go back and plug that in. 10 minus 7 does equal 3, so we know we have the right answer. Okay, example B right below it. Now we have x plus 4 equals 9. And again, if you're just starting out, it kind of means blank plus 4 equals 9. We want to know what x has to be. So we have a plus 4, so the inverse of plus is a minus. Or the opposite of addition is subtraction. So we're going to subtract 4 from both sides of the equation. 4 minus 4 is 0, so it kind of cancels out. That's what an inverse does. It undoes the operation. And we get x equals 5. And again, that should make sense because if you go back to the original equation, 5 plus 4 does equal 9. Now, example C. 3x equals 24. Now hopefully remember this. If we don't, if you just see a number out in front of a variable, that means multiplication. So if we see 3x, that means 3 times whatever x is. So the opposite of times, or the opposite of multiplication, would be to divide. So that little fraction bar is the same thing as division. So I'm dividing by 3. That cancels out. 3 divided by 3 is 1, so I just have 1x. And then I have to divide the other side by 3. X equals 8. And again, you can go back to the original equation. 3 times 8 does equal 24, so x has to be 8. And last but not least, example D. Now we have x over 4, and it kind of looks like a fraction. Remember, a fraction is the same thing as division. You need to make yourself a note. Sometimes we're afraid of fractions for some reason. It's just division. So the opposite of division would be to multiply. So if I took this times 4, that's going to undo my division. And then I take the other side times 4. So x equals 24. And again, check your answer. If I plug my x in, does 24 divided by 4 equal 6? Yes, it does. All right, next let's talk about reciprocals. So this is an important word in math. A reciprocal is a number that can be multiplied by another to get 1. So in a way, we kind of used reciprocals on example C and example D above. A reciprocal is kind of like flipping a fraction. So if I have A over B, the reciprocal would be B over A. Basically, if I multiply those two together, I should get 1. Okay, so reciprocals can be used to help you solve equations that contain fractions, okay? So example A, we have 4/3 x equals 8. So in order to do this, to get rid of this 4/3, I just want 1. So if I want to get a fraction to equal 1, I multiply by its reciprocal. So I'm going to take that times 3/4. But whatever you do to one side, you have to do to the other. So times 3/4. Okay. So 3/4 times 4/3, this cancels out this right here. And you just get 1. It equals 1. So 1x, or just x. And then 8 times 3/4. If you're multiplying fractions, what you can do is you can multiply by the top number and then divide by the bottom number. So 8 times 3 is 24, divided by 4 is 6. So x has to be 6. All right. Example B. Now I have a negative 2/5. Oops, this is missing its x. I just realized that. Add an x in there. Maybe I can go back and fix that typo before the copies come in. But if you don't have an x, I want you to add an x there. That's a typo. We have negative 2/5 x. I'm going to multiply by its reciprocal. You do want to multiply by the negative as well, okay? So we want to multiply by another negative number. If you remember anything from last year or previous math classes, a negative times a negative gives you a positive. And our goal is to get x by itself, to get a positive 1x. So I'm going to take it times, I'm going to squeeze this in here, times negative 5/2. You got to flip it. So if you take negative 5/2 times negative 2/5, you should get 1. So then I multiply this side by negative 5/2 as well. Remember, this little dot means multiply. Okay. So on the left side, I should get 1. When you multiply something by its reciprocal, you get 1. On the right side, I should get negative 15/2. Or if you want that as a decimal, if it makes more sense to you that way, we could do that. It should be negative 7.5. Okay. Solving two-step equations. So this time we're going to have 2 things to do. Two-step equations are often solved by using the inverse order of operations. So if you remember PEMDAS, please excuse my dear Aunt Sally. Since we're using inverses, we kind of go backwards. So you want to add or subtract before you multiply or divide. You go backwards. So if I have 2x plus 5 equals 13, and I want to get x by itself, first I have to get rid of that plus 5. So the opposite of plus 5 is a minus 5. So to get rid of plus 5, subtract. So on the left-hand side, I still have 2x. My 5 is now gone because I subtracted it out. And then over here, I would have 8. Okay, now I have 2 times x. The opposite of times is to divide. Divided by 2, and x equals 4. Okay, let's try the next one. I just realized my order is kind of wonky. Let's just go ahead and do C, and then we'll skip to the next page. All right, x over 5, remember that over 5 means division, minus 2. So first thing we want to do is take care of any addition or subtraction first. So we have to take care of this minus 2. Do the opposite by adding 2. So I have x over 5 equals 4. Okay, now to get rid of my division, I do the opposite. The opposite of division is to multiply. So I multiply by 5 to get rid of it, times 5. X equals 20. There you go. All right. Example B. So sometimes example B kind of tricks some people because our x is not out in front. That's okay. The 4 and the negative 6x, those could be switched around. Like if you wanted to, you could easily take that and you could flop it around like this, and the 4 is positive, so you could add 4. These are the exact same thing. It doesn't matter what order those two are in. Okay, but if I was solving this as it's written, I have to do the addition and subtraction first. The addition or subtraction actually happens with that 4. I can't get rid of the 6 yet because the 6 is being multiplied to the x, and I have to do that last. So we get rid of the 4 first by subtracting, even though there's not a plus in front of it. So we can subtract 4 because 4 minus 4 is 0, so now that's gone. But I still have a minus 6x equals, let's see, we do get a fraction here. Do I want to leave it as a fraction? A fraction, what am I doing? I'm subtracting. I'm acting silly right now. Okay, 22 minus 4 is 18. Now we're going to divide. I was getting ahead of myself. So we got rid of the 4 by subtracting. Now, since my negative 6 is attached to the x, that means multiplying, so I want to do the opposite and divide. I do want to include the negative in there and divide by a negative number. Okay, 18 divided by negative 6 is a negative 3. Remember, anytime you're multiplying or dividing, if you have a positive divided by a negative, you get a negative. But if you had like a negative divided by a negative, then you would get a positive. So try to remember some of those rules. Next one, again, you have to add or subtract before you can multiply or divide. So we need to take care of that negative 6 first by adding. Negative 3 plus 6 is 3. Now I have that fraction again, 3/5 x. To get rid of a 3/5 x, if I just want 1x, I have to multiply by the reciprocal. So flip it, times 5 over 3. 5 over 3 times 3 over 5 is going to be 1. It kind of cancels out. So times 5 over 3 over here. So 1x on the left, those cancel. You get a 1. And then over here, you actually just get 5. And there's your answer. All right, this last little section is equations with variables on both sides. So we're getting a little bit harder as we go on. Now notice, everything I've given you so far, the x is on the left side. X can be on the left or the right side, it doesn't matter, but you do want to get x on one side. I always do that first. That's just a preference of mine. Now, when you do have x on both sides, it can get a little bit confusing. I recommend drawing a line through your equal sign. That might help you, okay, if you get confused on where x is at. So first step is to get x to one side by adding or subtracting. I'm going to take this 2x and I'm going to try to move it over to the left. In order to get rid of it, since it's positive, I have to do the opposite and subtract it. 2x minus 2x is 0. So now I have to come over here and subtract 2x from the left side as well. So let's write down what we have. 3x minus 2x is 1x, or just x. My negative 5 is untouched. My 2x is gone, because that's 0. And then I have a 4. And then this looks just like the other equations we did. To get rid of the minus 5, we're going to add 5 to both sides. X equals 9. Okay, so let's do another one. Again, kind of helps to draw a line. Now, I can go left or right. I can take my 7x and I can move it over to the left. Or I could take my 4x and I could move it over to the right. It doesn't matter. Just be careful with your negatives. I always like x on the left. So I'm going to take that 7x and I'm going to move it over to the left. It doesn't matter. Okay, and let's write down what we have. I have a negative 3x because 4 minus 7 is negative 3. My plus 7 is still there. My 7x is gone because 7x minus 7x is 0, and then I still have a negative 2. Okay, and remember, you have to add or subtract before you can multiply or divide. So we have to get rid of this plus 7 first. Negative 3x equals negative 9. And then I can divide both sides by negative 3. And there's your answer. Pause and try this one, please. And then when you're done, unpause and we'll go through it together. Remember, we want x on one side, everything else to the other. So first step is always to take your x, move it over. I have a negative 6x this time, so I'm going to add it to get rid of it. Then I have to do the same thing to the left as well. It's going to be negative 5x minus 10 equals negative 55. Now we have to work to get x by itself. So if it's not an x, it needs to go over to the right. You have to add or subtract first. Negative 5x, that's gone, equals negative 45. Divide both sides by negative 5. X equals 9. So that's all we have for this lesson. There is a part B to topic 1. So you're going to watch that video as well. That one goes over the distributive property. That gets more into like the level 3s for this scale. Okay, so make sure you go straight to video B.